Okay, so a lot of today is going to be more practice of what we've talked about. So we've talked about a few different ways to find missing whatevers of right triangles. Okay, so go ahead and turn your paper over and let's talk about these different ways we can find different measurements of right triangles. Okay, so turn your paper over, blank side. Okay, so the first way when finding a missing side of a right triangle. We know a couple ways how to find a missing side of a right triangle. Okay, the first way, you guys have learned this since you were little freshmen, is Pythagorean theorem.
Well, not me.
Oh, maybe not. Okay, but we talked about it earlier in this unit. Okay, so we talked about Pythagorean theorem. Remember Pythagorean theorem, a squared plus b squared equals c squared. So we use Pythagorean theorem when it gives us two sides and we're trying to find the third side. Okay, gives us two sides, we're trying to find the third side. For example, give yourself a little example here. It gives you like 3 and 4 and you're trying to find x. Right? It gives you two sides. You're trying to find the third side. We use Pythagorean theorem. Okay, the second way we can find a missing side of a right triangle is, we'll just call it trig. Short for trigonometry. Okay, remember your trigonometric ratios? So,
No.
ka,
No.
and toa. Okay, so this is what we're talking about when we're talking about trig, sine, cosine, and tangent. Okay, we have to use trig in order to find a missing side of a right triangle when it gives us, so now draw yourself a little example again, it gives you a degree and a side. So let's say this is like 21 degrees, I don't know, whatever degrees you want to make it. Okay, it gives you a side and then you're trying to find a missing side. Okay? So that's our second way, when it gives you an angle and a side. Notice that's different than Pythagorean theorem. With Pythagorean theorem, it gave you two sides. Okay, let's talk about our third way to find a missing side of a right triangle. And this is when our special right triangles come into play. Okay, so we can find the missing side of a special right triangle because we know how those sides started out. Okay, just like on our starters. So let's remind ourselves of our two different types of special right triangles. Okay, our first guy was our 45, 45, 90 triangle. So whenever you see a 45 degrees, you know it's got to be a special right triangle. Okay, and the sides of this special right triangle start out as 1, 1, and root 2. That's how they start out. So you can find the missing side because you know what these guys started out as. Okay, so that was our first special right triangle we talked about. Our second right triangle we learned about.
Already got it down.
Good job. Is our 30, 60, 90 right triangle. Okay, and these sides started out as, well, I know the 3's got to go next to each other, so this long side is root 3, because the 30 and the 3 go by each other. I know the hypotenuse of both of these guys have a 2 in it, but this one is just regular 2. And then the little side of this guy is just 1. Okay, awesome. Holy smokes. You guys are like upper level math. You know how to find a missing side of a right triangle 3 different ways depending on what it gives you. Okay, so let's go ahead and turn your paper over. Bless you. Okay, and tell me, for number 1, which way out of the 3 we just talked about do we have to use in order to find the missing side for number 1? Is it Pythagorean theorem, SOHCAHTOA, or special right?
Special right?
I don't see 60, 30, or 45. SOHCAHTOA. Nice. Okay, because it's giving me an angle and a side. Okay, so let's write that down. I know I have to use either SO, CA, or TOA for this guy. Okay. Well, we know from last time that whatever angle it gives you with these guys, that's where you're standing. So you're standing at 27 degrees. Gives you that angle, that's where you're standing. Now, based on where you're standing at that 27 degrees, what 2 sides are we working with? Opposite, adjacent, hypotenuse. What 2 sides does it give you?
Hypotenuse.
It does. It does give us the hypotenuse.
Adjacent.
And adjacent. You guys are great.
I love it.
Okay, so now you need to ask yourself, what function do you need to use? Which one, SO, CA, or TOA, uses adjacent and hypotenuse? CA. So we know we're going to use cosine for this. Okay, alrighty, let's do it. Let's set up our equation. Okay, so we're using cosine, so cosine of the angle, remember the angle always goes next to it, cosine of 27 equals adjacent, 14, over hypotenuse, x. Okay, now tell me you guys, because now we're just trying to solve for x. It just becomes another equation. So look at our side with our x. Can we solve for x when it's on the denominator? No, so what do we got to do? We got to move it. Nice. So what is the opposite of divide by x?
Multiply.
Times by x. So we're going to move it to the other side by multiplying by x. Okay, that gets it off the bottom. So now I have x times cosine of 27 equals 14. Okay. Well, now my x is on the other side. So now I need to look at that side because I need x by itself. So tell me, you guys, what is the opposite of multiply by anything?
Divide.
Divide. So now we're going to divide by cosine of 27. That gets rid of it on that side. Do the same thing on this side. That's going to give us our x all by itself. We just need to punch that into our calculator. So I'm going to bring out my calculator. I'm going to type in 14 divided by cosine of 27. Okay, let's round it to the nearest tenth, 1 decimal place. Is the 1 behind the 7 going to bump it up or keep it a 7?
Well, keep it a 7.
Keep it a 7. So final answer, 15.7.
I'm already ahead.
Nice job. Okay, awesome. We had to use trig, so SOHCAHTOA, to find that missing side of our triangle. Okay, let's try it again. Doing the same thing here. Okay, so we know we're standing at the angle it gives us. So it gives us 46 degrees. Ooh, super close to a special right, but not quite. That had to be 45. Okay, so we know we're standing at 46 degrees. Based on where I'm standing, what 2 sides am I working with? Opposite, adjacent, hypotenuse.
Hypotenuse.
It doesn't give me the hypotenuse this time.
Opposite.
Opposite, it does give me that one. And
Adjacent.
adjacent, good job. Okay, so it's giving me opposite and adjacent to work with, which means which function, sine, cosine, or tangent, uses opposite?
TOA.
Nice. We know it's got to be TOA, so we're going to be using tangent. Opposite and adjacent, O and A. Okay, so let's set up our equation. Tangent, T for tangent, of the angle, 46, equals opposite, x, over adjacent, 18.
And this one we can just divide, right?
Not quite divide. What's the opposite of divide?
Multiply.
Beautiful.
Okay.
Yes, Bella's absolutely right. This one's a little bit nicer because x isn't on the bottom this time. We don't have to move it. So we can just get rid of divide by 18. What is the opposite of divide by 18?
Times.
Times by 18.
Then you times the whole problem by 18 and you get your answer.
Yep. Now all we got to do is punch that into our calculator. 18 times tangent of 46.
Which I have already done, and I'll be very nice to give you it.
18 times tangent of 46. 1 decimal place. What is this going to round to?
6.
18.6, right? The 3 is going to keep the 6 a 6. So 18.6. Final answer. Okay, there's one of our ways to find a missing side of a right triangle. You guys are awesome. Okay, but now let's look at numbers 3 and 4. It's not asking us to find a missing side. What is it asking us to find?
Missing degree.
Which tells us what? It's not a side, it's an
Angle.
It's an angle, okay? So we're not finding a missing side, we're finding a missing angle now. Okay, so it's gonna be a little different, kind of the same as 1 and 2. So we know we're gonna be standing again at the angle it's indicating. Okay, so it's giving us this question mark right here. Let's go ahead and just call him X, right? In math, we like to label it X. I don't know what it is, I'll just call it X.
Question mark into an X.
Sure. So we're standing at the question mark, or the X now. What 2 sides am I working with? Opposite, adjacent, hypotenuse.
Hypotenuse.
It does give me the hypotenuse this time,
The opposite.
and the opposite.
It's going to be sine.
Nice. You guys are getting this off the top of your head. You know that the only function that works with opposite and hypotenuse is so. So that means we're going to be using sine for this equation. Now here's where it's different, you guys. Set up your equation, sine, but remember the angle always goes by the function. What is my angle? What did we label that question mark as?
X.
X. So this time it's sine of x, because we don't know what that angle is, equals opposite, 49,
Hypotenuse.
over my hypotenuse, 57. Okay, this is where my calculator is going to be your best friend here, because look at the side with our x. We need x to be by itself. Right now this sine is attached to the x. Well, what is the opposite of sine?
-1 sine whatever.
It's literally called inverse sine, which literally means the opposite of sine. Okay, so all it is a button in your calculator. To get x by itself, the opposite of sine is inverse sine. Cancels each other out. So now in your calculator, you're just going to take the inverse sine of that fraction over there. Okay, that's going to give us our final answer, our degree.
You want the final answer?
I'm going to show you guys how to type it in. Okay, so since it's the opposite of sine, you're going to need to click second.
That's right.
Second. Now click your sine button. There's your opposite sign. And it was 49 over 57, close parentheses. Round it to 1 decimal place here. What's that gonna round to? I want it to the first decimal place. 59 point what?
3.
0.3, nice. So we know that that missing angle has to be 59.3 degrees. So you know when you're finding a missing angle, you're gonna have to use that opposite button. Don't get intimidated, it's literally just a button in your calculator. Okay, let's try it again. So again, we're standing at the angle. It's question mark, we'll change it to X. So we can solve for X. based on where I'm standing. What two sides am I working with? Opposite, adjacent, hypotenuse. Hypotenuse is one of them again. Yep.
Adjacent.
Adjacent. Good job.
Which will give you what?
Okay, so then which function, so, ka, or toa, uses adjacent and hypotenuse?
A tower.
Not quite. Which one?
Co.
Ka, ko. Yep, you guys got it. It's the C one. Beautiful. Ka or cos. We're going to use cosine. Okay, so we know we got to use cosine. That's the only one that uses adjacent and hypotenuse. Okay, so let's set up our equation. Cosine of the angle, but we don't know what it is, so we call it x. Cosine of x equals adjacent 33 over hypotenuse 50. Okay, only one step to get my x by itself, you guys. What is the opposite of cosine? It's not a trick question. The opposite of cosine is what?
The opposite.
The opposite of cosine, the inverse cosine. Okay, so we get rid of cosine, or we get x by itself by doing the opposite cosine.
Negative cosine.
So in your calculator, you're just going to do inverse cosine of that fraction, which will give you your degrees, your missing angle. Okay, so let's go ahead and type that in. I have second button, cosine, see our little inverse cosine of 33 over 50.
The answer.
One decimal place, what's that going to round to? 58 point what?
It's no. 48. 0.7.
48.7. I want it one decimal place, 0 behind the 7, so it doesn't change it.
Yeah.
So 48.7 degrees. Great job. Okay. Numbers 1 through 4, we were using trig. So, ka, toa. Show me a fist of 5. How are you guys feeling about so, ka, and toa? That's pretty good. Pretty good. I like it. Okay. Here come the fun things. We're still trying to find the missing sides, missing side lengths. But these ones we aren't using, so, ka, and toa. What do you think we're going to use? What was our third method of finding a missing side we wrote on the back?
Cool formation.
Special right triangle. They're special right triangles. Okay, so refer to the back of your paper if you need to. So looking at number 5. Okay, this guy, we see our 60 degrees. Okay, so we know this is our 30, 60, 90 triangle. Right, that 60 degrees tells us that. Now let's go ahead and label how these sides started. Okay, well if that angle's 60, that side has to be 30. Okay, which means this side closest to my 30, right? The 3's are closest together. This side started as just root 3. Okay, on this special right triangle, the hypotenuse started as just a plain 2. And my small side started out just as 1. Okay, so let's see how they changed. It's going to help us find our missing 2 sides, x and y. How did we go from root 3, or what did we multiply to root 3 to get 4 root 3?
4.
Easy peasy. We started out as root 3. We had to multiply something to get 4 root 3. We know it's 4. Okay, so that's how the one side changed. It told us that. So now all we got to do is take our 2 other sides. So my first side is y. That guy started out as 1.
Why did you do this?
Started out as 1. We got to multiply it by 4. What is y going to turn into, that missing side?
4.
4. My other missing side is x. It started out as 2, but now I have to multiply it by 4. What's that side going to turn into? Good job, you guys. And look at that. You found your two missing sides. 4 and 8. Y became 4. X became 8. Beautiful. Okay, let's try that again. Number 6. We're given a special right triangle. Is this one a 60, 30, 90 or a 45, 45, 90? Ah, love that. Okay, at least we know you can identify that, right? 45 tells us this guy's 45, 45, 90. Okay, let's identify how these sides started, what their original sides were. We know that the hypotenuse of a 45, 45, 90 is root 2. It started out as root 2. That's the original. Okay, then the two other sides, remember, were just 1. Okay, so those were our original sides. Now let's see how they changed.
So 2 ones?
Yep, so they're equal to each other, 1 and 1. So, if this side started out as 1 and became 5, what did I have to multiply to the 1? 5. Oh, look at that. So we had to multiply by 5 to get that first side, which means we're going to multiply by 5 to find our missing sides. So my other side, this is going to be really easy. Other one, it's going to multiply by 5. What's the other side going to be?
5.
Also 5. Yes, they're always the same as each other. Now my other missing side, x, started out as root 2. We have to multiply it by 5. Ooh, what's that going to be?
10.
Not quite. It's not 5 times 2, it's 5 times root 2.
15.
So how would we write that?
I don't like 8 and 7.
We write it 5 root 2.
I don't like 8 and 7.
Okay? Donovan, you cannot multiply the two numbers because think of them, they're not like terms. Okay? So you just put the 5 right in front of the root 2 and you're good to go.
I don't like 8 and 7.
Yes. Okay. Let's only do 1 out of 7 and 8. Which one do you guys... You want to do 8?
Yeah.
Okay.
What about 9?
So now, you guys, we are dealing with what we call special right triangle multi-step, meaning there's more than one step. Okay, how many triangles do you actually see here? 2. Yeah, there are 2 triangles we're working with. Okay, let's go ahead and focus just on the top one for now. He's still a special right triangle. Which type of special right triangle is he? 60, 30, 90 or 45, 45, 90?
60 and 45, 90.
Which one? 60, 30, 90 or 45, 45, 90?
45, 45, 90.
60, 30, 90. Okay. So, that 60 told us. Okay, so let's identify what the side started out as. Same start as the other guys. Okay, this long side next to the 30 degrees started out as root 3. Short side started out as 1. And then the longer side is just a plain 2. Okay, but it had to change somehow. How did we go from 1 to 5? What did we multiply to 1 to get 5?
5.
5. Okay,
5.
perfect. Okay, so that means since we went from 1 to 5, we had to multiply by 5. Okay, so let's go ahead and just find these other missing sides, even though they don't explicitly ask for it. Root 3 times 5. This side is going to turn into 5 root 3. Boom, boom. It changed to 5 root 3. Other side went from 2 multiplied by 5. What's that side going to turn into?
10.
10. Nice and easy 10. Okay.
But then one side is 10 now, so we need to do 10, right?
Yes, okay.
Oh my goodness, I
Now-
paused that immediately.
20.
Now we're working with our second triangle, which is this guy right here. What type of triangle is that one? 30, 60, 90 or 45, 45, 90?
45, 90?
45, 45, 90. Okay? Well, we know, you guys, that the sides, the two legs in a 45, 45, 90 are equal to each other. So if this one's 10, what's this one?
10.
It's also 10.
10 and then
I
10 of root 2.
Oh, you guys are so good. Okay? And then we know in a special right triangle, if you look on the back of your paper,
Good guess, by the way. I'm surprised I actually got it.
no, you got it. Because look at our original right triangle. 1, 1, technically this is 1 root 2. So whatever these sides are, they just go in front of that root 2. So on number 8, since our sides are 10, we know that our x has to be 10 root 2. And look at that. You guys found your missing side of a multi-step special right triangle.
That was a lot of steps for
Yes, you guys can do it.